Black holes are the most terrifying objects in the universe. They are regions of space where gravity is so strong that nothing, not even light, can escape. But what would actually happen to you if you fell into one? The answer is stranger, more terrifying, and more mind-bending than anything you have ever imagined. Today we explore exactly what happens when you fall into a black hole. A black hole forms when a massive star dies. When a star many times larger than our sun runs out of fuel, it collapses under its own gravity. The collapse is so extreme that all the matter gets compressed into an infinitely small point, called a singularity. Around this singularity, gravity is so powerful that space itself gets warped beyond recognition. There is a boundary around the singularity called the event horizon. Cross that boundary, and there is no coming back. Not for matter, not for light, not for anything. Imagine you are floating in space, and somewhere ahead of you, there is a black hole. At first, you would not see much. Black holes are invisible. They emit no light, but as you get closer, you would start to notice something strange. The stars around you would begin to bend. Light from stars behind the black hole would curve around it, creating a ring of light. Scientists call this gravitational lensing. It is one of the most beautiful sights in the universe, and one of the last things you would ever see. As you fall closer, the gravity pulling on your feet would be much stronger than the gravity pulling on your head. This difference in gravitational force would begin to stretch your body, first gently, then violently. Scientists call this process spaghettification. Your body would be stretched longer and longer, thinner and thinner, until you become a stream of particles falling toward the singularity. You would be turned into cosmic spaghetti, long before you ever reach the center. But here's where it gets truly strange. If someone were watching you fall from a safe distance, they would never see you cross the event horizon. As you approach it, time would appear to slow down for you. From their perspective, you would appear to freeze, getting dimmer and redder until you faded from view entirely. You would never appear to cross the boundary. You would just stop, frozen in time at the edge of the black hole, forever. But from your own perspective, something very different happens. You would cross the event horizon without even noticing. There is no wall, no barrier, no alarm, just a point in space after which the laws of physics as we know them no longer apply. Inside the event horizon, all paths in space lead toward the singularity. There is no direction except inward. You cannot turn around. You cannot stop. You are falling, and nothing in the universe can stop you. At the center of the black hole lies the singularity, a point of infinite density, infinite gravity, infinite curvature of space and time. Our physics breaks down completely at the singularity. The equations that describe our universe produce answers like infinity and division by zero, which means we have no idea what actually happens there. Some physicists believe the singularity is where space and time end. Others believe it is a doorway to somewhere else entirely. A tunnel through space, a gateway to another universe. We do not know, and we may never know, but the story does not end there. Stephen Hawking discovered that black holes are not truly black. They slowly leak energy over billions of years. Eventually, a black hole will evaporate completely. But here is the problem. When a black hole evaporates, what happens to everything that fell into it? You fell in. Your atoms, your memories, your information. Where does it go? Physics says information cannot be destroyed, but black holes seem to destroy it. This is called the black hole information paradox, and it is one of the greatest unsolved problems in all of physics. The greatest minds of the last century have argued about it for decades. Nobody has solved it yet. Black holes are not just terrifying. They are the universe's greatest mystery. They are places where our understanding of reality simply breaks down, where space ends, where time ends, where the laws of physics we depend on stop working. And somewhere out there, at the center of our own galaxy, there is a black hole 4 million times the mass of our sun. It is called Sagittarius A star, and it is 26,000 light years away. Close enough to study, far enough, for now, to be safe. What do you think happens inside a black hole? Comment below. We read every single one. If this video blew your mind, hit the like button. Subscribe to Cosmic Truths for mind-blowing facts every week. See you in the next one. But let us think about this on a deeper level. Black holes are not just objects in space. They are windows into the fundamental nature of reality. Every law of physics we have ever discovered was tested here on Earth, or in our solar system, or in nearby galaxies. But at the singularity of a black hole, those laws stop working, which means our understanding of the universe has a hard limit, a boundary beyond which we cannot see, cannot calculate, cannot predict. Einstein's theory of general relativity, the greatest theory in the history of physics, breaks down at the singularity. Quantum mechanics, our best description of the subatomic world, also breaks down. Neither of our two greatest theories can describe what happens inside a black hole. To solve this mystery, we would need an entirely new theory of physics, a theory that unifies gravity and quantum mechanics. Scientists have been searching for this theory for over 100 years. They call it the theory of everything, and the black hole may be the key to finding it. Because here is the most extraordinary thing about black holes. They are not just destroyers, they are also creators. Scientists believe that at the center of almost every galaxy, including our own Milky Way, there is a supermassive black hole, and these black holes may have played a crucial role in forming the galaxies around them. The most destructive objects in the universe may also be responsible for creating the conditions that allowed stars, planets, and life to exist, including us. And here is one final thought to consider. When you look up at the night sky, every point of light you see, every star, every galaxy, is sending light that left it thousands of years ago. Some of those stars no longer exist. They collapsed into black holes, long before that light ever reached your eyes. You are looking at ghosts, light from objects that are already gone, swallowed by the darkness, and somewhere in that darkness, a black hole is waiting. Patient, silent, invisible, the universe's most perfect trap. Black holes do not care about us. They do not care about anything. They simply exist. The most powerful objects in the universe, silent and invisible, waiting at the edge of everything we know.